Today we'll be doing 10-6 in your book. Last class we talked about tangent lines, lines that intersect the circle in only one point. Today we're going to talk about secant lines, lines that intersect the circle in 2 points. Now we're going to go over the different types of angles in circles and learn the last few and how they're related to their intercepted arc or arcs. I'm just going to remind you again about the 2 types of angles we've already learned about. A central angle, where the vertex is the center, and the sides are radii. Remember that the central angle was equal to its intercepted arc. The other angle that we've already learned about was the inscribed angle. Remember that the vertex was on the circle and the sides were chords of the circle. This was the intercepted arc. And we learned that the inscribed angle was equal to 1/2 its intercepted arc. Now we're going to look at a few different types of circles. First, we're going to look at the one where the vertex is on the circle. But instead of the sides being chords of the circle, the sides are going to be made by a tangent and a secant line. In this case, from the point of tangency to the second point where the secant intersects the circle, that is the intercepted arc. Next, we're going to look at an angle where the vertex is inside the circle, but not the center. This occurs when 2 secants, or 2 chords, intersect, like in this picture here. When this happens, there are 2 intercepted arcs. When we have 2 segments intersecting like this, we get vertical angles, 2 pairs of vertical angles, and remember that vertical angles are congruent. I'm going to focus right now on this pair of vertical angles, angle 1 and angle 2. Because they are congruent, we can figure out the measures of both of them by using each of their intercepted arcs. Note that this picture is different than the ones we've been looking at so far because it has 2 intercepted arcs instead of 1. And finally, we have angles where the vertex is outside the circle, and there are 3 ways that this can occur. We can have 2 tangent lines intersecting, outside the circle, like this picture. When that happens, we get 2 intercepted arcs here and here. Notice that the entire circle is broken up into those two arcs. So the measurements differ by 360, or the orange arc's measure is 360 minus the blue arc's measure. The blue arc's measure is 360 minus the orange arc's measure, or together their measures add up to 360. A second way we can have the vertex outside the circle is by a tangent line and a secant line intersecting. Here, once again, we have two intercepted arcs. In this case, the secant and the tangent break the circle up into three arcs, two that are inside the angle and one that is outside the angle. Remember that the angle's measures are only based on the intercepted arcs measures and not any other arcs on the circle. Finally, we have the case where we have an angle with the vertex outside the circle made by two secant lines. This breaks the circle into four different arcs. These two are the intercepted arcs. And these two are outside arcs.
Now you're going to do your first investigation. Click on the screen to go to Google Drive and do that investigation. Now click here to do the next part of the investigation